So here we are having apparatus for getting the characteristics of a thermistor. The connections are very simple. Here is a thermistor, right? And we are having a power supply variable with this knob. We are connecting the power supply to the thermistor. This connection to here and this connection to here. In series with the thermistor, there is a resistance R, this one, and a milliampere meter. And across the thermistor, what is voltage? Across the thermistor, there is a voltmeter in parallel to the thermistor. So these are the connections. So second end of the thermistor is connected now. Second end of the thermistor is connected to the voltage. Now connection is okay. Now keep in mind the temperature bath is off. We are not heating the thermistor now. In the first step, heater is off. So this is a knob where you can have voltage and milliampere from this digital scale. If knob is up, it is ready for voltage. If the knob is down, it will measure the current. So this is variable here, variable knob, increasing the voltage. Okay, voltage is 1.03. Now current is 0.59 milliampere. So temperature is constant, which is the room temperature, 33 degrees Celsius. So you write here the voltage and the current in milliampere. Then again voltage, and we are varying. Now it is 2 volt, 2.0567, 2.06 you say. The current is 1.17 milliampere. So 2.04, 1.17 milliampere. Now voltage is 3.07 voltage, and current is 1.79 milliampere. Okay. Now the voltage is 4.06 volt. Current is 2.4 or 2.41 milliampere. Now voltage is 5.05. Current is 2.92 milliampere. Now voltage is 6 volt. Current is 3.56 milliampere. Voltage is 7.07 volt. Current is 4.36 milliampere. Voltage is 8.04, current is 5.22 milliampere. So voltage is 9.02, current is 6.17 milliampere. So I think the data is sufficient to draw the graph between voltage, and current. Okay. Now this is all about voltage and current. Now look, I have plotted a graph between voltage and current. Current, it is in milliampere. The graph is like, first of all, the starting, it is slightly curved, but just crossing this point, it is a straight line. If the graph is straight line between voltage and current, it tells us about that that when the voltage is between 4 to 10 volt, then the resistance is constant. Resistance is more or less constant. Okay, before 4, the resistance is variable, but just crossing 4 to 6, it is more or less constant because it's a straight line. And temperature is constant throughout which is the room temperature. Temperature was constant. Graph is between voltage and current. Current in milliampere. Now we are going to perform the second activity of the thermistor, where the voltage will be constant, now 3 volts. We'll note down the temperature and current, and keep in mind the room temperature was 33 degrees Celsius. Now this line is 40 Celsius, 50, 60, 70, 80, 90. This was 30 degrees Celsius. Okay, voltage will be constant, and the data will be between temperature and current. So temperature is 33, note down. Current voltage is 3.01. Now current is 2.03 milliampere. Now switch on the hot bath. Now temperature is rising. So temperature is going to 40 degrees Celsius. Current is 2.99 milliampere. So at 45, current is 3.7 milliampere. At 50, it is 4.28 milliampere. At 55, current is 4.98 milliampere. At 60, current is 5.5 milliampere. At 65, current is 5.9 milliampere. At 70, it is 6.27 milliampere. At 75, it is 7.16 milliampere. At 80 it is 7.58 milliampere. At 85 it is 7.84 milliampere. At 90, going to touch the 90, it is 7.84 milliampere, and this is sufficient data. Okay. Now, one thing you do, note down please. We know that thermistors are of two types: negative temperature coefficient and positive temperature coefficient. Negative temperature means when the temperature is rising, they show a decrease in resistance. Positive temperature means with increasing temperature, they show increase in resistance. The thermistor which we have, here is a thermistor. It is NT. NT means NTC, negative temperature coefficient. Mean as the temperature is increasing 30 to 80, 90 degrees Celsius, what happens? The resistance drops down. Resistance becomes less. Resistance becomes less, then the current will increase. Because you know very well, if resistance goes down, the current will definitely increase. Okay, when the current will increase, there is some voltage across R and some voltage across the thermistor. So when the current will increase, here the voltage drop will also increase, voltage across R. So what happened? The voltage across the thermistor also goes down with the increase in temperature. Just look. I'm looking what is the voltage here at 90 degrees Celsius. What I am getting? 1.33 volt. Whereas the voltage which was set, it was 3 volt. The voltage drops to 1.33 volt. So this is, a limitation, because we are saying the temperature is we are saying voltage is constant throughout. It is not constant, it also going down. So this is a limitation. We are noting down the temperature and current, the precaution, what is the voltage across the thermistor. So if you kept the temperature again at the same value, mean 3 volt, note down what will be the current then. Okay, current will be then, now note down the current. Current is 13 point something ampere. So the value of the current now changes. Okay. So this is the limitation here. Now, I plotted a graph between, the data was temperature, resistance, the data was temperature, current, voltage was constant. How much? 3 volt. We need the values, data between temperature and resistance. So you find resistance dividing the voltage by current each time. But you take the current in ampere, not in milliampere, 1 milliampere is 10 raised to power minus 3 ampere. So you divide V by I, then you will get R. Then you plot the graph between temperature and resistance. The temperature is going up, temperature is increasing, and note down the resistance. So this is the value of the resistance in ohm, because I have taken current in ampere, not in milliampere. Then I divided voltage to that current which was in ampere. Then I am having the unit ohm. So this is the graph. Now this is important here. You choose any 2 points, and actually the point should be close, but I am taking a gap. Okay, ideally the point should be very close. Now I call this temperature as T1 and this resistance will be R1. Now I call this temperature as T2 and here the resistance is R2. Now I will find what is alpha, temperature coefficient. So here the temperature coefficient, it is defined as change in resistance R2 minus R1 per unit resistance mean divided by R1 per unit increase in temperature mean divided by T2 minus T1. You are having all the values. You are having R2, R1, R1 and change in temperature. You find what the value is. So here we are getting the value of alpha minus 0.099 per degree. Per degree Celsius means R2 minus R1 it is ohm, R1 it is in ohm, the unit cancels out, only we left the unit temperature in the denominator. So that's why per degree Celsius. And at what temperature? We are having the two temperature 29 and 45. So this will be alpha at the lower temperature. Lower was 29. So this is alpha at lower temperature 29 degrees Celsius. The value is this much. Now if you see the table, for silicon the alpha is of this value. For germanium alpha is of this value. What do you conclude? That germanium having in magnitude more value of alpha as compared to silicon. But you are having other value. So what do you think? The thermistor which you was using, it is made up of which material? Tell me in the comment box. I am again performing another activity where I'll try to keep the voltage constant with increasing temperature. So voltage and current from here. Now this is room temperature. This is room temperature, okay, 33 degrees Celsius. Then switch on the heater and current, note down what is the current flowing. Now current is increasing because the temperature is increasing. What you do? You each time you try to keep the voltage constant by varying this knob 3 volt. Each time you fix the voltage 3 and then you note down what is the current and temperature. Each time fix the voltage 3 volt and then note down what is the temperature and current. Okay, so this is a little bit difficult, but it will be then the accurate experiment. You can just pause the video and then note down what is current and temperature when I am fixing the voltage constant, which is 3 volt. Then you will have the correct data between temperature and current, because each time we are fixing voltage 3 volt. So this is all about how the error can be minimized in this experiment. Okay, thank